So yesterday we talked about the sum and difference of sine and cosine. Again, it's one of those where we're adding or subtracting different angles, and we have specific formulas in which to use for that. And we learned yesterday that we cannot, if we're adding two angles, we cannot just distribute make that tangent u plus tangent v. We saw how that does not work. So therefore, we have specific formulas given when we're adding two angles with sine, adding two angles with cosine, and now today we're going to be talking about adding or subtracting those two angles with tangent, okay? At first I started to say in the previous hour that this is going to be a little bit more complicated than the others, but after we got working it, it's really not. Actually, this one's a little bit easier, because if you look at this, when I'm adding two angles with tangent, the numerator is still adding. So the sign is the same, but if you look at the denominator, the sign changes, okay? And that's the same for both. So here, when I'm subtracting, the numerator is subtracting, but the denominator becomes adding. So here, the signs are same in numerator, but different in the denominator. Okay? Signs are same in the numerator, but different in the denominator. That is a complete bunch of shorthand. The signs, plus and plus, minus and minus, are the same in the numerator, but they're different, plus, minus, minus, plus, in the denominator. Got it? Okay. All right, so now let's put this to work. Everything else is going to be exactly like what we did yesterday, because what we're doing is this is helpful when we have an angle measurement that isn't directly on our unit circle. So we have 105 degrees. So just like we said, we're going to take tangent of 60 plus 45. That's the same thing as 105. And those two angle measurements are on our unit circle, so that's why we're pulling the 60 and the 45 out. So knowing the 60 is our first, the 45 is our second. Also, please know that these can be written as 45 plus 60. That order doesn't matter, okay? It's not like the biggest always has to go first. That doesn't matter, so I can flip-flop those. So now we're going to plug it into this formula up here. So we have tangent of the first, which is 60, plus tangent of the second, which is 45. All over 1 minus, and it's minus because the numerator is positive, or is adding, and so we do the opposite on the denominator. And then I'm going to do tangent of the first times tangent of the second angle. And this is where then we pull out a unit circle, and we pull the values off of our unit circle then to find tangent of 60 and tangent of 45. So tangent of 60 is square root of 3, and tangent of 45 is 1. All over 1 minus tangent of 60 is square root of 3 times tangent of 45, which is 1. Now we're just going to clean that up a little bit to put it into standard form. And the radical goes at the end. 1 is not under a radical. I cannot combine them anymore. So I leave it as 1 plus square root of 3 over, radical's already on the end in the denominator, 1 minus square root of 3, and that is my final answer. We are not rationalizing. Okay? Any questions? Now the second one, just like what we had yesterday, is in radian measure. So therefore, just to make it a little bit easier to find the two different angles to add or subtract, we're going to go ahead and convert to degrees, but then convert back to radian measure, okay? Just because it's fun. So we're going to take 13 pi over 12 times 180 over pi to get to our degrees. And yesterday we did a lot of 180 divided by 12. That was 15. And then we'll take 15 times 13. Multiply that out and you should get 195 degrees. So 13 pi over 12 is the same thing as 195 degrees. So two angle measurements from our unit circle that add or subtract to be 195. Anybody? How about 135 and 60? Does that sound good to you? Sure, let's use it. But now I want to convert back into radian measurement, okay? So that's going to be written as tangent 135 is 3 pi over 4. And 60 degrees is the same thing as pi over 3. Okay, so those are the two angle measurements that I'm going to be working with right there in radian measure. So then, this is still a plus. Poor notes on my part. Okay, plus, plus. We don't have a minus on there, but just it's done exactly the same way. But just watch your sign is what you have to watch out. And tangent's kind of nice because you're not having to worry about I'm flipping over to sine or I'm flipping over to cosine like what we saw on the front. So here we go. So I'm going to take tangent of 3 pi over 4 plus, that's the first angle, tangent of the second angle, which is pi over 3. All of that is over 1 minus, since it's plus in the numerator, it's going to be minus in the denominator. Tangent of the first times, this time, tangent of the second. Next step is where I actually convert it into the value. What is tangent at 3 pi over 4? And tangent at 3 pi over 4 is -1. And tangent at pi over 3 is square root of 3. All over 1 minus tangent of 3 pi over 4 is -1 times pi over 3 is square root of 3. And again, I'm going to kind of clean it up. Both of these look like they're already in standard form with the radical at the end. So I will leave it at the numerator is -1 plus root 3 over 1. Two negatives make a positive plus positive 3. And that's how I will leave my answer. Okay, we're really kind of cheating the system a little bit by not rationalizing, but again, as we're seeing in some of our standardized tests, that the rationalizing could become a thing of the past, even though it's still an irrational number in the denominator. But so we are going to leave it as it is. Okay? So questions on utilizing tangent now of those two formulas of adding or subtracting. We go with that? Okay. So now the next two is another type of proof. But in order to prove it, we need to utilize our sum of two angles, okay? So we're utilizing these formulas that we just worked on, okay? Or we just discovered. And again, it's one of those things that right now we're bombarded with things called fake news. We want to make sure that these are not fake identities. So these two that we see down here have been on your identity sheet, okay? So let's prove it. Let's take it to court and make a case for it. So I have cosine of x plus pi over 2 equals the opposite of sine x. We've seen that on our identity sheet. That was more towards the bottom. And so I've got cosine adding two angles together. This is what we did yesterday. So if you want to have your formula sheet out instead of flip-flopping back and forth, or if you want to flip-flop your notes back and forth, that is fine as well. So we're going to have, so we have cosine. So we're going to have cosine. Cosine is same functions, but our signs switch. So I'm going to take cosine of the first angle times cosine of the second angle. Okay? So my plus becomes minus with cosine. And then I switch from cosine to sine. Sine of the first angle times sine of the second angle. Does that really equal the opposite of sine x? All of that converts down to negative sine x. Are you kidding me? How in the world will that happen? Cosine x might throw you for a bit, but since I have no idea what x is, I'm going to leave it as it is. So I'm going to say cosine x. This time I'll remember to put the s in. Cosine of pi over 2, look on your unit circle. What is cosine of pi over 2? Cosine's in the x value. It is 0. I don't know what sine x is, so I'm going to leave sine x. But what is sine of pi over 2? That is the y value. How much? 1. Can you see where we're headed here? Anything multiplied by 0 is 0. Anything multiplied by 1 is itself. And there it is. So I get the opposite of sine x really does, I was not kidding, equal the opposite of sine x. Okay? Utilizing that same strategy, except now we're going to do it for tangent. We're going to prove that tangent x plus pi over 4 equals 1 plus tangent x over 1 minus tangent x. So utilizing the formula that we just learned today, I want you guys to go ahead and work out the proof for this tangent one. And hopefully when you get finished, you see I really wasn't pulling your leg. It really does equal.